Good morning, afternoon, or evening, ladies and gentlemen. How you doing today? Welcome back to Mr. Moore's Algebra 1 and 2 class. We're going to continue with rational expressions, and this time we're going to take another piece, and we're going to find the LCD, the least common denominator. Let's just go back to old school stuff. For example, 15 and 5. Okay? What's the LCD? If you remember, you would list out all the multiples of 15 and all the multiples of 5. What's the lowest common multiple between 15 and 5? It's 15. Okay, multiples are always equal to or larger than the original number. Factors are always equal to or less than the original number. So it'd be 15. Okay, yes, sir. Yeah, I put denominator. Let's say it was 1 and a 2. Okay. So multiple is just regular denominator. You are correct in that sense, okay? So that's what we're looking for. The lowest common multiple between these two numbers. Well, in this case, we're looking for the lowest common multiple between two polynomials. So let's see how this works. In order to add and subtract rational expressions, you must find an LCD. We just found that out in the previous lesson. You have to have a common denominator. To find the LCD of several rational expressions, follow these steps. This is gold here, guys, gold. Factor all of the expressions in the denominator completely. Factor all of the expressions in the denominator completely. So you're going to have several different denominators. Factor them all out completely. Factor them all out completely. And I mean completely. Negatives, if you need to take out a 2, factor them completely. I don't want to be a broken record, but it's really important, y'all. Okay? Number 2, the LCD, please pay attention, is the product of common factors raised to the greatest power times the non-common factors. I promise you I will show you what that means in just a couple minutes. But go ahead and write this down. The LCD is the product, that's multiplication, of common factors raised to the greatest power times the non-common factors. I promise you I'll tell you what that means now in a second. Right now, we're not going to look at denominators. Right now, we're just going to look at the common multiples just so you can see how to write them properly according to this product thing that I'm telling you about. Okay. The least common multiple, let's go one by one, between 12 and 18 is 36. Okay. What's the least common multiple between x squared and x? X squared. Very good. I'm proud of you. For the LCM of exponents of variables, it goes to the largest exponent. For the GCF of exponents, it goes to the smallest. Very good. It's reversed. So that's x squared. What's the the LCM between y and y cubed? Y cubed. See what I mean now by common factors raised to the greatest power? Do you see what I'm saying now? Y and y are common factors, but it's raised to the greatest power. Yes, sir.
Didn't step 1 say that you only do the one to the denominator?
Yeah, but right now I'm just doing LCM just to show you how it works out. Okay. So now let's factor. Let's factor this bad boy right here. This here is x plus 1, and here this is x plus 1 plus 4. Okay, now this is where people get a little confused. Okay, on this side of this problem, how many x plus 1s do I have? How many do I have on this side? But doesn't this say it's the product of common factors raised to the greatest power? So who has the greater power, x plus 1 squared or x plus 1? So that's what I mean by common factors to the greatest power. And then I have an x plus 4 here, right? Do I have an x plus 4 here? So I need another x plus 4. And that will be my least common multiple. Talk to me. We're going to have examples all day today. Yes? All right, let's see another one. Find the LCM. Okay, let's factor this bad boy here. I factor out a 2 and I got x plus 2. And here I factor out, this is going to be x minus 3x plus 2. Is everyone with me so far? Just pretend these are denominators if you want. I'm just showing you how to write the least common multiples together. Of all these multiples, think about it. We got to write the product of every single common factor or common multiple to the highest power, or any non-common multiples or factors. So I have a 2, which I need. I have an x plus 2 here and an x plus 2 here. So all I need is one x plus 2. And I have an x minus 3, which must be combined as well. That's my LCM. I combined both of those together. I needed a 2, so I have a 2. I need an x plus 2 and an x plus 2, so I just need one x plus 2. And then I also need that x minus 3. You guys are a little quiet here. Talk to me. This is my job, you know that. It's my pleasure. Continue? Okay. Let's find the LCM of this bad boy. Okay, these are 3. Pretend these are 3 fractions and these are the denominators. This first guy, I've got x plus 4 times x minus 1. This guy got x plus 4x minus 2. Thank you. And then here, x minus 2 and an x plus 2. I want everyone to factor that first. Wait, did I screw up? Did I screw up? Oh, that is a minus 2. Thank you, son. Thank you. I did screw up. Thank you. Awesome. Great job. Go ahead and factor all of those, please, guys. And then hopefully we'll start seeing what I'm talking about. Remember, the LCD, remember like if you had like 1 over 15 plus 3 over 17, don't you easily find a common denominator by multiplying the two together? Yeah, right? Well, that's what we were doing here. So I have an x plus 4 and an x plus 4, but I need an x plus 4 here, correct? So x plus 4 is going to be my first factor. I have an x minus 1. I need an x minus 1 here and here, so x minus 1 is also part of my factors. I have an x minus 2 here, and then I got 2 x minus 2's here. So I need x minus 2 squared. That's my boys. That's my boys. Yes. Yes, sir. It doesn't matter if you put it first or second or third. Why would it be x minus 2 squared? Thank you. How many x minus 2's do I have here? 2. And don't I always go to the highest power of the common ones? Thank you, my brother. Now, I promise we're not going to do this, but just to give you a little eye-opener to tomorrow, just think. If this was my LCD, what do I have to multiply to this guy to have my LCD? X minus 2 squared, right? Because I already have the x plus 4 and the x minus 1, right? What do I have to multiply to this guy to get the LCD? An x minus 1 and an x minus 2. Excellent. What do I need to multiply to this bad boy to get x plus 4 and x minus 4? Yes. And remember, whatever you do to the denominator, you must do to the numerator. Okay, that's all I want you to think about. I promise I will not complicate this today, but just so you can know what's coming. All right, now let's do it. We're not going to do anything but simply find the LCD. You have my word. Okay, what's the LCD of 15 and 18? Is it going to be 80? No, not 80. 270? No. 90? What times 18 is 90? 18 times 5. Giddy up. Thank you. So 90. What about the x? How many x's do I need in my LCD? 3 cubed. And how many y's? Squared. Done. Done. How do you do this though? What happens? Just so you know, you don't have to do this. But I would multiply now 6, because I need 6 times 15 to get to 90. I need an x squared, and I don't need any y's. I need to multiply at the top and bottom. To this guy, I'd have to multiply 5y to top and bottom. Now from here, multiply this, add the numerators. I already have a common denominator, and then I would simplify. Do you see where this is going? Okay. No more of that, though. Let's just stick to LCDs, I promise. Okay. So this denominator is x minus 2x plus 1. And this guy is x plus 1, x plus 1. What would my least common denominator be? An x minus 2, I need that in both of them. And I need an x plus 1 squared. Yes! What would I multiply to this one to get the LCD? An x plus 1 to numerator and denominator. What would I multiply to this one to get my equivalent fraction? An x minus 2 to both top and bottom. You guys with me? This isn't that bad, is it? Told you. Told you. I knew you guys would be able to do this. Okay, this is a great one. This is x plus 5, x minus 5. Now, what did I tell you about this when the x is negative? What do I want you to do first? Well, let's in this case factor out a negative 2, right? But this is what we'll do. When we rewrite this, this is x plus 5, x minus 5. This is now going to be minus 9 over 2x plus 10. No. 2x minus 10. Do you see what I did there? I factored out that negative and immediately I brought it up so I don't forget. I want to do a negative first to show you what I do with the negative. Now let's factor out the 2. So I got x minus 5. So what's my LCD? A 2 times x plus 5 and x minus 5. What would I need to multiply to that denominator? A 2. What would I need to multiply to that denominator? An x plus 5. No, because the negative I brought up here already, remember? That's why I did the negative first. Thank you, sir. Does that make sense, boys? Bring up that negative immediately, guys. It's going to save you a lot of heartache. I promise. It's not that bad, right? Yes, sir. The example 5, the LCD is x minus 2 times x plus 1 squared. Thank you, son. May I continue? Let's do this. All right. Now, why is this? Oh, that's messed up. Okay, well, I don't know why it came up like that. It says forming equivalent rational expressions. Equivalent rational expressions. Now remember, whenever you want an equivalent fraction, you must multiply the same value to both the numerator and the denominator. So step 1, rewrite each denominator in factored form. Step 2, find the LCD. We already know how to do that. Step 3, rewrite the equivalent rational expressions using the LCD by multiplying the missing factors to both the numerator and the denominator. We're still not going to add them together today. I promise. We are going to convert them, though. We're not going to add them, I promise, but we are going to convert them. So rewrite each denominator in factored form, find the LCD, which you know how to do. Then you're going to rewrite equivalent rational expressions using that LCD by multiplying the missing factors to both the numerator and the denominator. Is that cool if I go there?
Yeah.
Promise?
Yeah.
Okay. So let's do this, guys. We're not going to add them. I just want to find the LCD and rewrite them so I can be ready to add them. So here, this is x plus 2, x plus 1. And this here is x plus 2 times x plus 2. Okay. What's my LCD, gentlemen? Oh, man. Wow. Come on, Morrow. Difference of squares. Come on, Morrow. Thank you, guys. What's my LCD? On x plus 2? No, not x plus 2 squared. Just an x plus 2 times x plus 1 times x minus 2. Okay. So, what do I have here? I have this 4 over this x plus 2 times x plus 1. What must I multiply to top and bottom to give me the LCD? On x minus 2. Okay, and then over here, I have 9, x plus 2, x minus 2. What do I have to multiply to the numerator and denominator there to get my LCD? On x plus 1. I'm going to stop there for a second. Does everyone see where this has been flowing now? Talk to me. Thank you, son. X plus 2 times x plus 1 times x minus 2. Yes, I did. Here's an x plus 2. Here's an x plus 1. Here's the x minus 2 that I'm going to multiply. Here's an x plus 2. Here's an x minus 2. Here's the x plus 1 I'm going to multiply. Now, let's go ahead and multiply it. What's x minus 2 times 4? 4x minus 8 over x minus 2, x plus 2, x plus 1. Am I going to multiply the least common denominator together? No way, unless you want to torture yourself. And I have 9x plus 9 over x plus 2, x plus 1, x minus 2. Now in this point, now I can add the numerators together and I have my LCD already. Talk to me, boys. Yes, sir. Thank you.
So the answer would just be adding the top.
If I was adding these together, my answer would be 13x plus 1 over x plus 2, x plus 1 times x minus 2. Because that's my LCD that I have already found and converted. But for today's lesson, you just have to go to the setup. You don't have to add them together. Let's do another one. Okay. What's the LCD here, gentlemen? Between 6 and 21st. 60, very good. Between a squared and a? Between b and b cubed? Okay. What do I need to multiply to this denominator to get to look like this? 10b squared. What do I need to multiply to this bad boy to make it look like the LCD? 3a. Very good. So we're not going to add them, but let's just convert them and prep it. This will be 30b squared now over 60a squared b. Plus or minus, I don't know. That's why I put an and. Minus 15a is b cubed. Sorry. Yes, b cubed. Over 60a squared b cubed. And now if I wanted to, I can add it or subtract it. But again, for today's lesson, just wanted to make sure you got the LCD, and then you can convert them and make equivalent fractions. Yes?
What would you do if you added it? Because
If you added this together, let's say you were adding them, they're not like terms, so the answer would be 30b squared minus 15a over 60a squared b cubed. And then from there, I could factor out a 15 if I wanted to, and then I could reduce the 15 with the 60. But it's not simplified, but that's what it would become. And then you would have to factor it out. That's for tomorrow. All right, last page. Find the LCD of the rational expression, then rewrite the rational expression with the LCD. Okay, so I got an x minus 5 or an x plus 1. And here, I got an x minus 5 and an x minus 2. What's my LCD, y'all? X minus 5, x plus 1, x minus 2. What do I need to multiply to this guy? An x minus 2 to both top and bottom, giving me 5x minus 10 over the LCD of x minus 5 times x plus 1 times x minus 2. And what do I need to multiply to this bad boy? An x plus 1 to both top and bottom, giving me negative 3x minus 3 over x minus 5 times x minus 2 times x plus 1. Does that make sense?
yes.
All right, guys. You can leave quietly. I'll finish the last problem, but go have lunch. Thank you. Have a great day. Leave quietly, though, so I can record it. Thank you. Quietly, guys. Quietly. So here, rewrite 3 over 4p squared minus 8p with a denominator of 16p cubed minus p times p minus 2. First of all, let's factor this out. I can factor out a 4p, and then that gives me a p minus 2. So if this is the LCD, what do I have to multiply to 4p times p minus 2 to get me this LCD? Well, if you guess 4p squared, you are completely right. So now this would be 12p squared over 16p cubed times p minus 2. And once again, you have converted a rational expression. Thank you very much. I think we're done. Yeah, we're done. So have a great day, and I hope you learned a lot.